Okay, guys, so we're talking about variables. So when you have an experiment, and I'm just talking about experiments here, case studies, surveys, and naturalistic observations do not have any variables that you manipulate. Only experiments do. And so for the next part of our notes, we're only talking about experiments, not the other types of research methods. So we have two types of variables. We have independent variables and dependent variables. And it's very important on the AP test that you can tell the difference between these two, that you can determine which one is independent and which one is the dependent, or you can make up your own independent and dependent variables. So an independent variable is anything that you're going to manipulate in the experiment. So let's say that you were doing, I remember doing this experiment in like third grade, where you have these little bean seeds and then you plant bean seeds in two different pots, and then you put one by the sunlight and then you put one in the closet, and you see which bean plant grows the most. Obviously the one that's getting the sunlight. But whatever is being manipulated in this experiment, in that experiment, it was the sunlight, whether or not the plant was getting sun or not. And so you're manipulating the amount of sunlight that they have. For psychology experiments, a lot of them are going to be dealing with like medicine. Give this group 10 milligrams of Ritalin, and then again this group, a placebo or something like that. And so hopefully the independent variable brings about change. If you're trying to see, what type of drug helps with ADHD or helps with depression, hopefully the drug is going to help with ADHD or depression, whatever you're trying to experiment. And so typically if you see an experiment and it uses a drug, the drug is the independent variable. It could also be different things. So let's say that I wanted to test whether, cold in a classroom increases test scores. And so I'm going to have one classroom be regular temperature, and then one classroom I'm going to crank up the air. And so it's going to be colder. I'm manipulating the temperature of the room. And so that's the independent variables, whatever you are changing. The dependent variable is the result. Their test scores, how high the bean plant actually did grow. It's whatever is being measured. It's the result of the independent variable. It is dependent on the independent variable. The height of the plant is dependent on how much sunlight it had. The test scores is dependent on how cold the room was. It is the result, is what you're measuring after the fact. So if you're measuring some sort of like drug and how that changes sleep patterns, the drug itself is the independent variable. How it changes your sleep patterns, the amount of sleep you got, or how awake you are, that's the dependent variable. Okay, there are also other variables. Those are the main two, the independent and the dependent, but you also want to be aware of something called a confounding variable. So let's say that the object of the experiment is to prove that A causes B. A confounding variable is anything that would cause B that's not A. So let's say that you're trying to prove that smoking causes cancer, and experiments have already done that. But a confounding variable is anything that might cause cancer that's not necessarily smoking, and that could be lifestyle. That could be maybe it runs in their family, so they have genetic characteristics that would lead them to be have more cancer or something to that effect. Okay, so here's the experiment. If you want to prove that smoking causes heart issues, what are some confounding variables? It's anything that would cause heart issues that's not smoking. Bad diet, poor exercise, genetic predisposition, stuff like that. Okay, so how do you get rid of confounding variables? Because in every experiment, there's going to be some amount of confounding variables. How you want to get rid of it is by having sampling and random assignment. So first you have to identify the population you want to study. So let's say you want to study all of Tomo High School students. Well, that is your population.
Good morning, teachers. Hope everybody's having a great.
Okay, I'm back. So you first want to have a population. The population is the people that you want to study. And so, like, if you want to study the entire world, then your population is the entire world. But if you're really only trying to test, children from the ages of 7 to 17, then that's your population. Or if you want to just do adults that smoke, then that's going to be your population. And then you are not going to test everyone in the population, because that would just be crazy, to have an experiment where every single person of Tom High School participates in. It would be too expensive. It would take too long. It's just too much of a hassle. So you're just going to get a sample of the population. And so you have to have a random sample. A random sample would not be passing out flyers to everyone in the hallway during passing periods, because number one, not everyone has an equal opportunity to be in the sample. Because what if you're not in the hallway during that passing period? What if you're running late? What if you're absent that day? What if you don't take that hallway? Not everyone has an equal chance, and that's what it means for it to be random. Everyone has an equal chance to be selected as part of the sample. So you got to get a random sample. And you have to have a stratified sample, meaning, let's say the general population of Tomo High School is 4% male and then 46% female. Well, then your sample needs to have that exact same percentage of population. If you have a random sample and 90% of them are male, that's not very random. And it's not a very good representation of what Tomo High School actually is, because that's not the characteristics of the population of Tomo High School. Same thing, not just like male and female, but for maybe sexuality, if that's an issue, or race, religion, age, where you need to make sure that the sample is a representation of the population you're trying to experiment on. Okay. And then you take that sample. So let's say we have 3,000 people at Tomo High School, and you're going to have a sample so the population is 3,000, and you want to have a sample of just 300. Okay, so now you have 300 sampling of the population, and that you randomly got. You picked ID numbers. You had a random shuffle of ID numbers. You picked names out of a hat, something like that. And then you're going to take those 300 sample, and you're going to equally split them randomly, like heads or tails, randomly, odds and evens, something like that, into two groups, the experimental group and the control group. And so the AP test really needs you to know the difference between population, sample, experimental group, and control group, and how you get all those things randomly. And so the experimental group is the one that's getting the independent variable, the one that we just talked about, whether they're getting the drug. Are they the plant that's getting the sunlight? Are they the people that are getting the colder temperature rooms to take tests in? And then the control group, they're going to not get the independent variable. That's what makes the control. You're going to be comparing the results of the experimental group to the results of the control group. Control group didn't get anything, so it's like what you're basing all your information off of. So the experimental group, they get the independent variable, they get the drug, they get whatever you're manipulating. Both groups are going to have some sort of result. The test scores, the height of the plant, or whatever it is, the result of the drug. And you're going to be comparing the dependent variable between the experimental group and the control